Okay. Good afternoon. I am Anto Budiajo. Welcome to Monday Live. This is something that we do every Monday afternoon to figure out the future of smart buildings and smart building technologies. We are listed on mondaylive.org in case you are wondering who we are. And just as a reminder, views expressed here by us and audience and anybody else are personal, not of any company or organization. And please do post questions and comments on the Zoom chat. We really want to make this as interactive as possible. Also note that this slide deck that I'm showing is available on mondaylive.org, just in case you want any of the links that we have on it. So as I briefly mentioned last week, for the month of March, we're going to be talking about AI. Specifically AI in buildings. That's obviously a very hot topic right now. So we'll see how interesting that is and how productive we can be in talking about AI. So our agenda, no more chit chat, figure out what's going on, and then AI in buildings. And today, really what we want to do is sort of set the scene about a discussion about AI. And what we're going to do is we're going to ask the panelists and also any one of you in the audience to chime in as to what we all think of AI's role in buildings, or how AI is going to fit in buildings. Just sort of frame the month's conversation that way. So we won't go into too deep into any specific topic. Just get everybody's views and maybe discuss that quite a bit. But before we do that, I want to hand it over to Ken to update us on what's going on his perspective. Ken?
Thanks, Anto. Of course, first thing I like to do is do a shout out for International Women's Day, which is on Wednesday, March 8th. We're getting some support on our site, getting the women in our industry to identify themselves and call out to others to join. And I think this is an important movement now as we're hurting for talent, and there's a lot of talent waiting in the wings and a lot of capable women. Also on the AI front, when I made this graphic, we just had our first post, I guess, from the women. Now I've had Sudha has basically identified a whole bunch of women who were involved in AI, which is kind of an interesting post as well. So it's just now on the site. I'm also working on my next article for Connected Contractor. And the title of it is, it's basically a sequel to the Creative Community Collision, and it's called The Inclusion of AI's Value. So it would have been nice if we'd have been through this month by the time I wrote that, but I had to reach out there and pull in some of the stuff we had. And some of the stuff we had is that one of the posts on LinkedIn from a contributing editor and one of our sponsors, they kind of do a little bit of a chit chat and talking about the future of AI and IoT. Sorry about that. And Chat GPT just keeps coming up. It's pretty hard to pick up any kind of articles now that don't have some reference to it. It's interesting too. I follow the LinkedIn posts fairly close, and just some of the comments are amazing, and some of the stuff they link to. And this was one of the ones they link to is the basically the talking building. And I think a lot of that is going to happen out of AI. I think we're going to see a lot of movement in self-driving devices coming into our space. One that kind of jumps into my mind that I have is like a Dyson, the conditioning system, and comes with all of its components, and it's your kind of personal device. I think we're kind of heading towards that, and I think that'll fit quite well in the conversion of large buildings from office buildings to space. We're going to start to see that. We're going to see these things coming with a lot of, I believe, AI intelligence built into them. We're starting to see that edge devices with cameras are becoming an intriguing trend. And the idea of actually sensing stuff without touching it or being part of it is an interesting concept for us, I think, as we physically have been installing stuff for years. Anyway, some interesting stuff. Looking forward to today's meeting. Back to you, Anto.
Thank you. Thanks, Ken. And Scott just reminded everyone that March is Women's History Month, in addition to International Women's Day. So I don't know whether that was
yes,
coordinated or not, but that's thank you. Thank you, Scott. I had a couple of pieces here. The first on the left is that I think some of you may have seen it last week. There was quite a bit of news from Washington, from White House, and also from NIST about an impending standard for post-computing cryptography standard that to come out from NIST next year in 24. Obviously, people are starting to take that concern very seriously in terms of how we're going to encrypt stuff when we have quantum computing all over the place, which is not that far down the road. So that's very interesting. The two links, one is an article about this, and the other is the piece on White House website on that. And the thing on the right is actually not a million miles away from what you were talking about, Ken. Here in this specific case, it's an article about window washers of skyscrapers becoming robots, which actually makes a lot of sense, because sort of watching people out there, human beings out there, is always unnerving to all of us. But the interesting thing about this is that it sort of makes the argument that this may well clean the windows, but it can also do a whole bunch of other things, including if you stick a LiDAR and some cameras on the actual rig itself, it can automatically, and obviously over time, every time it cleans the window, it can actually do an outside assessment of the building to figure out things like leaks and heat loss and all that kind of stuff. So I think this is a sort of a trend of lots of data coming from all over the place, and their use is not the most obvious one, right? Because you wouldn't actually think of data from a window washer cage to actually be useful to HVAC, and this is kind of their point here, is that data is just data, and you can actually use it in many different ways, as this is talking about. So I thought that was interesting. The other thing before we finish is that I've created this new slide that I propose we're just going to leave here for on Monday Live. And what we're going to do is populate this with links to interesting stuff. So last week we had Greg from Kaba talking about the podcast. So if you're wondering where the link is, it's right here. And you can see this deck, and there's links here for the Div 2525. And I've put some links to some events. And when we think there's links that will be useful, this is where we're going to put it. And you can always find it. You go to mondaylive.org, and this is on the homepage. You can follow it just in case, if you want to have these links. So that's all I had. Any other thoughts that anybody want to chime in? I see.
Right, I did notice that UL have decided to get involved in ESG. They've now expanded their operations to help people, it says, navigate through ESG with advisory and assurance offerings. So it's interesting sort of body to be able to actually start coming into that as well.
Last night on 60 Minutes, I don't know if anybody on the call today actually saw it. They had an interesting piece with Diane Sawyer talking about AI and chat GBT, and how the head of Microsoft, who is leading that effort, she kind of called them to the carpet about stuff not being accurate. And it's kind of interesting just to kind of see that. And then as a sidebar to that, I just posted in the chat, already starting to see how to prepare for chat GBT, AI, whatever, cyber attacks. So, you know, we're not there yet, and we're already talking about attacks. So anyway, just thought I'd share that with the group today.
Well, the first attacks will come from the robots at McDonald's, is what I hear, Mark. So if you haven't heard the latest update, there's a McDonald's in Fort Worth now that's fully automated, no people, or robotic,
Cooking as well as serving.
apparently.
Yeah.
Hmm.
It's kind of
Is it a dine-in, Anno, or just
No, it's
drive-through?
no sitting room, order to go, you leave. There's no sitting space at all. And it's all just windows.
with multiple drive-through lanes kind of a
Yeah.
thing. So very highly efficient for takeout.
And you got to remember, I love robots.
And
So,
McDonald's.
Yeah.
Yeah.
And
So-
Don't
next-
mess with the robots that fix
Right.
your food, right?
so the next thing you'll see is you'll get that Boston Robotics, you know, we all have seen those videos. They'll run out to your car and give you your burger and your fries when they're not ready, you know?
whether you want it or not.
Yeah, yeah.
Do a little flip on the way back in, right?
So a couple of comments on chat here. Scott was talking about a similar thing to the window washer, but garbage collection trucks to monitor not just garbage collection, but the condition of streets. Again, same thing, data being used for purposes other than their primary reason for capturing. So that's very interesting. And Audrey is talking about algorithmic Justice League. Maybe we can bring her on later and explain that.
Yes.
That'd be really great. So let's hang on there, Audrey. So any other thoughts before we move on? No, good. So AI in buildings. So this week, we really want to talk about the role of AI in buildings, or what we think the role could be, should be, can be, or maybe shouldn't be. And I've kind of structured these 4 questions, and we can have other questions and other perspective as well. But how does it, where will AI add value is kind of one of the ways of thinking about it. And how does it help us humans, other than, I know, being nice to them? And another question is, in terms of disruption, where is it going to disrupt? Who is it going to disrupt, and how it's going to disrupt? And the other thing is the timeline. I mean, obviously the whole ChatGPT is sort of exploded onto the scene within like 2 months, and you know, at that rate, you know, what's life going to be like in 5 years? So that whole sort of, these are kind of just some of the questions, and we can think of maybe others. So open it up to the panel. Anybody want to jump in? And
I'd kind of like to open the question as well, a little bit related to the first one, is where do we think that, where it says where will I add most value? It's also a split, how much will be at the edge and how much will be in the cloud. If we think back to perhaps the 80s and 90s, when we had self-learning optimization, self-tuning control loops and stuff like that began to creep in. But obviously this is what we've now got, is more compute power and knowledge that can go on. It'd be just interesting to see how much is needed, you know, almost dynamically, as opposed to, you know, if you like, on-prem and at the edge, rather than your bigger assessment stuff in the cloud.
yeah,
I wouldn't mind talking a little bit about how we're defining what AI is, and maybe more importantly, what AI isn't.
Yes, good point. And I think we kind of had this session on the Wednesday call. I think it'd go back to and the difference between AI and machine learning too.
Yep.
Confuse those a lot.
you want to start, Tracy?
Yeah, I don't know if I'm the best subject matter expert on this to do it, but I think part of the issue is that everybody is throwing the AI tag or label onto their products, and sometimes that's accurate and sometimes it's not. Maybe it's just, and when we were talking on Wednesday, we were looking at a couple of definitions, one of which stated that machine learning is just a subset of AI, and AI is more of a general purpose label for a number of different sort of sub segments or techniques used to create automation of various kinds and levels. But before we jump into where is it valuable and what will it do, I thought it was important to kind of get maybe a little census here among the group about what do you consider to be AI versus something else, just machine learning or just automation, or where do you draw the line between automation and what probably a lot of people think of as AI, where it's much more autonomous.
And Ken, you had that link that we used on Wednesday that I thought was a good little snapshot of the difference between AI and ML as a starting point too.
Tracy, I went on Wikipedia and to see what it's a very, very long description. And to your point, it breaks it down into a lot of different topic areas. So I guess having read it, my feeling is to try to distill the definition of AI down to one sentence or two sentences is going to be really, really hard because it covers an awful lot of ground. And so, at a high level, when I think it dates back to 1950s when Turing, basically said, can machines think? And so when you put it in those terms, basically anything we can do potentially can be done artificially now through software. So that covers a lot of ground, obviously. So, and, early on, we started using AI to optimize difficult control algorithms, neural networks, fuzzy logics. That became a science project in the 80s, became products in the 90s and beyond. So those were early examples of using artificial intelligence to deal with complex control challenges where you had multivariates that you try to optimize against, not just one simple temperature loop. So yeah, that's, I guess my opening comment is I think it's going to be very hard for us to define and contain artificial intelligence other than just saying it's whatever humans are capable of doing. Artificial intelligence is going to try to duplicate that.
So maybe if we looked at this as a range, as a scale, on one end might be something as simple as automation that we've had around forever, schedules and
Right.
and reacting to sensors of various kinds and so forth to perform certain tasks, control algorithms. And on the other end is something that is looking at large data sets from multiple implementations and use cases, and both making decisions about how to deal with a particular set of circumstances going forward, also looking historically to develop trends and understand how to identify faults, things of that nature. So we talk a lot about FDD, we talk a lot about machine learning, both of which I think we'd all agree is a particular vertical or subset of overall AI. But just to make sure when we talk about this in this context, it doesn't have to be a turnkey building that heals itself and fixes itself and completely runs itself and so forth, right? There are a bunch of little edge cases that we discussed where AI is really practical and in use today already, being deployed and growing in value and growing in application, I think, across different building segments.
Yeah, exactly. To your point, when video started, cameras video surveillance started becoming popular 20, 30 years ago. And you'd go into a security room and you'd see a bunch of monitors all over the wall from individual cameras. Right? And then now what do you have? You have cameras that have all kinds of intelligence in them where they can do facial recognition. They can count the number of people in the image and beyond that. So, and how does that compare to what human beings were doing? The person at the monitor could stand there and try to count, and they could try to recognize somebody, but are they going to be able to do it at the speed of computers? No, of course not. So that's a really good example of how you're applying AI technology to something that a person can try to do, but from a practical standpoint, on a 24/7 basis, isn't going to happen, and isn't going to happen as accurately.
And
So-
that's how I actually think about AI, generally speaking, is that it's effectively a lot of the things that we humans do and can do, but at a different scale or in a different way, right? So if you start there, you actually start with what we do, and
Right.
what we do is varies depending on who we are, and that's we all know that, and so I suspect it'll be the same with AI, but the capabilities will be manifold more.
So this is an example, right, of some of the confusion between AI and ML, and Ken's posted that screen, and I see Keith's given some good input too. So everything that you guys are talking about is clearly AI. So, the easiest one to describe or think about when you talk about AI is something like an Alexa or a Siri, right? Where it's designed to mimic something that people do today, or do things that people do. So the examples and use cases you gave was just perfect examples of AI. Is a machine going to do something that a person can do today? The other side of the equation is machine learning, which is really where you have a machine understand volumes of data, and then to be able to analyze that and do something with that particular data. The machine itself may or may not actually physically do anything with that data. It might only be represented as a result or an outcome or something that it should pass on to somebody to go do. So, a good example that I think Audrey will touch on it later, hopefully Audrey, would touch on it later, would be, reading in, volumes of energy data from all the energy sources of your building over the last 20 years and taking that and being able to predict some energy profiles or do some predictive analysis. So that's more machine learning, the outcome of which is not going to be used by the machine to physically do something. It may, which is the next step, right? And then to go off and do that. But AI was pretty much what you guys were talking about, where you're asking the machine to do what people do today. And so Alexa and Siri is always the good examples that people give in that world.
So people in the audience, if you want to come on, please raise your hand and I'll bring you on and make sure that you're ready. You just put up your hand on the Zoom. Sorry, I don't know who I interrupted.
Okay, I just I posted McKinsey's definition there for you, Anno. Sorry, I did it wrong. And that's in. They've kind of simplified it for all. I kind of like it because there's not just our industry. They're trying to. Everybody's struggling with this definition as well. The one thing that fascinates me is that when two machines talk, they don't go through all the iterations we go through as humans. Like we typically convert stuff to pictures, or we convert stuff to data strings, and we go through painful processes to do that. But when two machines actually share information and make a decision, they actually do it right at a code level, and they're extremely efficient at it. Just imagine something like a picture. What Steve was talking about is using video analytics. It's, we're looking at the pictures, trying in their mind, trying to figure out what it is we're looking at and trying to make a decision. The machine's looking at the code, and if one number is different than the other number, there's something in the picture that wasn't in the picture last time. So I know that in a heartbeat. So we're kind of moving into a whole new dimension of thought, I think, and it's just, I find that extremely fascinating. That's one of the reasons the machines can outthink us, is they don't use all these cumbersome processes we use.
Well, there's
Yeah.
no judgment. There's no reliance
Well,
on,
No,
It's not a
mostly.
judgment thing. We reduce things to something that we can understand and comprehend, communicate.
Mhm.
That's not necessarily judgment, although
Yeah,
judgment
sure.
comes into it.
Yeah.
But,
Hey, everyone, I'm going to add to the conversation. I unfortunately have to run to another work meeting, so I'm going to kind of throw a grenade into the conversation and run away. So Steve brought up a use case about surveillance. And so this kind of ties into that comment I just left in the chat about the Algorithmic Justice League and why we should be very careful with AI, especially when it comes to this interaction between people and AI. So what the Algorithmic Justice League is focusing on is how AI, because it's imperfect, because it's code written by people and trained on imperfect data sets, can accidentally reinforce racism, sexism, et cetera, in our system. So surveillance is a good example of, there have been, public surveillance, cameras on telephone poles, et cetera, that have identified people just in the public space, usually Black people, people of color, as criminals, people who are wanted, and they send that data to the police, but it's not them. It was done incorrectly. So that's why we need to be very careful with this kind of technology.
Yeah, as just a sort of a similar comment about any technology, it can be used for good, it can be used for bad, right? So
Right.
beware of unintended consequences.
Mhm.
And I mean, so many examples of that. Point is not to get into it, but I do think the way in which AI is mushrooming in its applications right now, and the types of things it's able to do, I think we're going to see potentially a whole slew of unintended consequences, to Audrey's point, that we're not going to be happy about.
Yeah, I mean, once you bring that kind of, let's just take the surveillance into a building, maybe you're using that to identify who's allowed in or not. What if it doesn't work, or it's
Right.
selecting people incorrectly? So, yeah.
Yep.
So comparing AI to human in that sense, it does sort of make me wonder that what you said, Audrey, happens with humans as well, right?
Mhm.
And whether we consciously know that we're making that decision, or if it's subconsciously we do it, we still make that mistake. And I'm wondering whether it's actually easier to fix in AI than it is in humans.
Couldn't tell you.
Interesting take on that.
Yeah.
Yeah.
This is Rick. I thought I'd look at that last bullet when you say the timeline, and I think that something that's come up a few times is like, all of a sudden now, and time has been part of what we're talking about here with AI all of a sudden being all over the news. And the timeline and the evolution of technology has something to do with all of a sudden why we're hearing all about AI. And the perspective of the chips and the software and the communication technology that are now possible, that weren't possible just up until a few weeks ago, has probably something to do with why all of a sudden the attention around AI has exploded. And everybody's attention, or everybody's knowledge and awareness of what's happening with AI in their lives, like my smartphone or my Tesla, I don't have a Tesla, by the way, or the different things that are happening with AI in other parts of their lives, they're now saying, well, have the chips and the software and the communication protocols gotten to a point where they can help me with my buildings? And that's what the question really is people are, maybe they don't know exactly what the details of AI versus ML are, but they know that computers have gotten faster, chips have gotten cheaper, harder to get also. Software is getting more complex. And so the now, or the timeline of can these technologies now finally help me with some of the mundane stuff in my buildings that I would love for a machine to do, so that people don't have to do it for me. or to do something better. But I think the timeline or the evolution of the technology is important to understand in terms of how did we get to this tipping point? And it's not a new concept. You know, we were talking about AI and ML 30, 40 years ago, but the chips and the processors and stuff were not capable of doing cost effectively what they can do now. And I think that one of the things we're going to do is dig into that.
So are you saying that we have the opportunity of figuring out what these things are that AI can do that would be helpful to buildings? In other words, because the technology enables us to do that, it gives us the option to do that where we couldn't have done that 20 years ago or even 5 years ago. Is that kind of the framing?
Yeah, and people have been saying in the last 15 minutes that, you know, it's nothing new that AI does. It's what humans can do now and machines can do. So we know what the math could do for buildings because we've been doing it ourselves as people for a long time. We know perfectly well what needs to be done to make buildings be better places, more efficient places, healthier places, use less energy. We know exactly what it is. So we should be looking at where can the new software, the cheaper chips, the cheaper processing and communication, where can that be used to do those things and be proactive rather than try and hold it back. But to Audrey's point, the mistakes that are made by people are going to just be made faster and stored in permanent memory instead of my faulty memory. And we do have to watch out for that because things that happen faster and happen by machines are somehow, more authoritarian or something. So yeah, we do have to be careful about things that just happen faster without some supervision.
In fact, just to that point, Rick, for those of you who've done anything in the ML AI space and tried to show it to customers or clients and stuff, one of the greatest challenges we have always had is what's called the explainability of AI. And so what happens is you put some analysis in front of someone, you go, here's what we found. The first question they always ask is, what's your algorithm? And then you have to say, well, there is no algorithm. It's all done through machine learning. And then they go, okay, well, explain it to me. Can you explain me what your algorithm, and they'll go back to using the term, is doing that generated this number or this value and stuff. And it is actually, especially in our markets, it's one of the biggest challenges we find in trying to explain what the machine is doing. And in fact, there's a new term now. It's called, I'll drop the link in from Wikipedia. It's called explainable artificial intelligence. So that, it's actually models where it allows you to be able to easily explain what's going on. We've had to do all sorts of tricks like showing, well, here are the parameters that we monitor and here's the impacts that those have, but how that actually derives to that number is you've got to understand neural nets and going through the space, which is a challenge, right? And people will go, okay, how am I supposed to believe your algorithm? And I'll keep using the word algorithm.
Is this something that is worse in ML than it is with AI? Is it?
Yeah, it is. It's
AI?
worse. It's actually worse in the ML cases because your machine's learning on the data and it feeds the data. And
It actually doesn't know. The machine itself doesn't know.
the
Whereas
machine itself probably can't explain itself in its fact, but you're required to. So it's a trap to watch for, if you start to get into the space and that your clients will ask you, please explain how this is working. If I'm making decisions on, I know Rick's run into this in many, many times. Please explain why you're changing my set point based on what this machine is saying. What's the algo behind this?
Yeah, so if John Petsy were here, he would say that you need to use the right tool for the job. And we've described this very often. It's the reason that most people in the analytics business use rules-based analytics rather than machine learning or AI at this point, because we understand the physics and the systems that we're analyzing. And by using rules-based analytics, we can basically give the root cause that's causing the problem. We have a pathway to get to that today. And one might even say that an AI or an ML technique may be an inferior technique to what we're already doing. However, there are plenty of great places that the technology can be used where it's hard to develop closed-ended approaches. And I can think of many, many applications in the configuration and setup of these systems, mapping of data, discovering of points lists, where I think ML and AI will be very important. You got to use the right tool for the right job.
And I think that's a really important point here, Jim, that people forget, right? It's not a cure-all to all things we do, right? There are absolutely good spots for it that you can think through. And then there are other places where we've got tools that have worked for quite some time. You don't need to change it. I think that's a bit of a trap people fall into as well. Well, can we use it for everything?
Yeah.
Well, does it make sense?
Well, there's an example.
Just one second, Keith, do you want to come on, Keith? Sorry, Steve, carry on.
Yeah, no problem. I'll wait. I'll wait.
No, you go ahead, and we'll bring Keith on later.
Okay, so auditing, from like a commissioning agent or a cybersecurity audit, it's today a lot of that is done very manually. And so I'm aware of a couple companies who are developing automated commissioning software that goes in and validates that the system is set up correctly. Okay, as an example, makes a ton of sense. Cybersecurity for sure. All these assessments, you ask somebody 40, 50, 100 questions. What about this? What about that? Right? And if as we are able to extract data and then orient that data against known right, wrong conditions, and you could basically be doing audits every day of the week, every hour, every minute, right? There'd be no practical limit to how often you could be auditing your systems to look for variances that shouldn't be there. But right now, what does that do? Well, that means, I guess, in two things. It's going to reduce the amount of consulting labor that is being sold today. But two, it's going to I think it's going to open up to lots of building owners the ability to audit their systems that they're not spending any money at all, right? So they don't even know what they don't know. But if this could be done in an affordable way, all of a sudden the quality of their control systems would become obvious, or the lack thereof.
David, we brought you on. David Katz.
Yeah, thanks. Two things. I was working on a nuclear power station with fuzzy logic and neural networks. So I was, goes back, 30 years ago. They were called expert systems. What I'd like to add is to build on what Jim just said, use the right tool for the right purpose. And, just watching 60 Minutes yesterday about kids using it to write exam papers, etc. Let's look at it from a building operations perspective. That's what's saving the money. That's what's been done with research, whether it's BrainBox, EcoPilot, Parity, they're all different, but they're all improving on if this, do that, which is what we generally program into our building operations. And in many cases, the systems don't even talk to each other until, Project Haystack lets it something talk to another machine, as Ken was saying, so that when you know that the chiller isn't doing what the specification says, you then be able to have a fault detection, but then you can also say, why didn't it do it? And you'll have data as to how it responded over every different temperature range. So I think we should stick to the building portion of it as opposed to the broader issue.
So the ability for a machine, AI or ML, I think this in this case is more AI, to be always looking at something is something that's unique to a machine compared to humans. We can't do that because we need to sleep and eat and things. That's a crucial difference.
That's what's being claimed by the programs that are being attached to the BAS. They're saying, we're going to read the weather coming to your building, and we are going to improve the performance greater than what a PI loop did or what was programmed to do it manually.
But also greater than the ability of a human or a group of humans to actually detect something.
It's doing it in real time, and that's not what alarms and, you know, faults are.
I think, what David said is quite interesting because a lot of things we brought up are components of, if you went back to the smarter stack and said, what's the purpose? What do we want it for anyway? You're kind of looking at trying to say, okay, is it a cost-effective method of, providing the right environmental conditions for either people or equipment, and, with preemptive fault analysis and reacting to changing conditions, what is the whole reason we're doing it? And a lot of the things we've been talking about here of control loops or people or even cyber and stuff are components of what the target, I guess, or the purpose should be around what AI is meant to be delivering for us in the building.
Yeah. And I think coming back to one of the things that I said earlier, Roger, just to that point is, I think we need to talk about kind of peeling off little applications within the building's environment, right? So we've hit on a couple of things. Keith put in a few notes that I think are really important to mention. So optimization is an important part that some kind of machine learning or AI can bring to the equation. And then in all caps, he included scale. So when you think about applications that we're involved with a lot, where there are literally hundreds or thousands of buildings, and being able to process and do all the things that you'd like to do on that scale requires either an army full of people or some kind of automation or machine learning or AI, right?
So let's just chat a little bit about that on the process side, right? And this is an area that I actually have a real being like bonnet about, and the application of it. So, we just talked about how machine learning or AI, whichever you want to use, I think it's more machine learning, but anyway, how machine learning can kind of like keep a constant eye on our parameters. And we've mentioned the companies who can take that data, feed it into some machine and then come back with here's really where the parameters are, the operations are. The part that I have the biggest challenge is that, for those of us who are into the controllers and know the control theory, you look at a VAV box, which is, got a double cascaded PID loop that you have to set up and configure to make it do correctly. No machine that I've seen yet has gone back out, done the analysis of that VAV box and come back and change the PID parameters of that VAV box. What everyone does today is the term I call is set point twiddling, right? I'll constantly adjust the set point every 15 minutes, which is not the right answer for how you fix that VAV box. You need to come up with what are the right parameters for that box in the first place and have a control, because it's a control system, and that cascaded PID loops have been around for decades and they work just fine. It's just that nobody really sets them up and configures them correctly in the first place, or does so after things change. And so there is a disconnect in my mind. I get it that you can get all the data, do the analysis, come back with the AI and go, here's what that box should be doing. But no one's really bridged the gap then and gone in and actually done the changes within the box, have reset the PID parameters. They're doing this, what I would call a cop out, this sort of set point adjustment model, which is, any controls engineer will go, well, yeah, dude, that's just not going to work effectively over the long term. I get the optimization part. I think the application of it has to be really closely looked at. And to your point, Tracy, that's where peeling back the onions into, okay, if I do the optimization now, where is it really succinctly applied? How do I actually take that and apply that and make something? Do I just provide parameters in a CSV file to some human and go, here, make these changes? Or do I actually go in and change the actual control algorithm, the control loops within the controllers? That's a major leap, right? Because no BACnet protocol supports that level of detail in a controller.
Yeah, and people, Tristan had some good comments in there too, building on the scale part of it, right? Scale doesn't just mean hundreds or thousands of buildings. It also means the amount of input data that we're looking at. You know, if you think he's got a perfect example there. Somebody who was actively performing energy management might look at things like rates and time of use plans and peak demand possibilities based on the weather that's coming, to do some pre-cooling, and as well as things like, oh, 3 bus full of high school students just stopped in after the football game. You know, all of these things humans could look at and kind of at least say, oh, I'm going to have a higher demand, or I'm going to have higher costs. What can I do to keep the comfort or avoid the cost? Right. But to do that at scale and continuously and equally under all circumstances all the time just is not practical using humans. Right. So that is a perfect kind of an application, as far as I'm concerned, for some form of AI or machine learning, right?
So let's talk about disruption. Where is AI going to disrupt us? I guess one obvious one that's come up several times is when we are expecting humans to do some of the things maybe that Tracy, you were talking about, observing stuff and trying to figure out. Obviously, we can't do it at scale, but sometimes we try. But that's going to be disrupted pretty obviously. But any other sort of places that's obvious that it's going to be disrupted?
I just want to throw a thing in here, just a marker in time. When I started into the industry, they told me that good automation was indistinguishable from magic. I think we're actually just about back to exactly the same thing with AI, and how we apply it is going to be controlled by a few. The result is going to be seen by all, and it will be perceived as magic. So I think that's an important just kind of perception. The other trend I see, very disruptive, is the fact that it's going to push out to the edge. The edge, I think AI will come from the edge. It will actually become the part of edge devices, and it'll have a greater gain there because it can actually see that there's nobody in the room. It can actually see that the temperature is wrong. It can actually, do a whole bunch of stuff. And because of what Dave mentioned, the continuous monitoring, it's just going to be so much more powerful. So I think we're going to learn from the edge back, and that's going to be kind of disruptive because we've kind of always been trying to look at stuff from the center out.
Yeah, I see this as a bit evolutionary as opposed to revolutionary, right? We're going to chip away at the edges all through it, and then all of a sudden one day we'll look back and be amazed at how much AI and automation we have built in that actually works, right?
And that will happen when lots of edges become AI enabled, and they start to coordinate with each other, presumably.
Yeah.
And the unwashed will identify it as magic.
Many of the buildings are set to the coldest day of the year and the warmest day of the year, and in between they are so poorly run. I mean, we have boilers that have 15 levels and people are high, medium, low. So I think AI is going to show, or ML is going to show, what the equipment should be doing, how it could be doing it better, and occupancy is key. I mean, we did a study where we had the gym full of people dancing versus one cleaner, and body heat changes the set point. So I think these are the things that we should be looking at just to make it better in the building space, including the productivity improvements that are claimed by finding the right place at the right time, or getting out of a building quicker if it's burning.
Yeah.
I wonder, going back to your question there, Anto, is whether one of the obvious targets is the application engineering, because we all kind of know that the pump's got to come on before the boiler or the chiller, and when people walk in the building, the lights have got to be on, and it is reasonably logical. And I wonder whether the tools for doing the application engineering will be one of those things where it could be disruptive, because as we all know, the way I write a control loop is better than the way you do, and yours is better than Anno's, and Anno knows his is better. And once standardization can come in, which is really all that it is, could actually be an area where it becomes very disruptive, providing that, because it's a logical use of tools.
And you're talking about almost sort of the basics, right?
Yeah.
The basics of flow is one happens before
Yeah.
something happens before something else, and that
Yeah.
never changes. And it's actually human to err, so it's actually much easier for us to make those kinds of mistakes, and AI is less likely to make those kinds of mistakes. We can then add the nuances, because those are things that we do far better than AI. Is that kind of the framing of it?
Yeah, and I was just thinking also that once it becomes dynamic, of course, it then can actually build into it the extremes of saying, hey, this is for the occupation of one person or a room full of people. I can adjust, the way the thing is applied.
That I'll build on that a little bit too. Another disruption, if you will, and we could argue how much of a disruption this is, but take a simple HVAC application like thermostats and rooftop units, right? A smart thermostat today generally means it communicates, right? It doesn't mean that it's smarter and does a better job at managing the temperature or managing energy or any of that kind of a thing, right?
Well,
And
sorry, just to interrupt, Tracy, it has that same PID loop that was invented 50 years ago. So
yeah, and you don't generally get that. At best you get an economizer control or something like that, or a multi-stage thermostat, a commercial thermostat. But generally what you don't hear anyone talking about, other than things like applying a schedule or setbacks, is any kind of intelligence around combining comfort with energy management, right? In a thermostat application. So taking and the goal of a thermostat generally is comfort first, and then it will use schedules or multiple stages or economizers for energy management. But we all know there's a lot more to that when you start looking at other factors like weather and rates and building resiliency and ability to recover from different temperature situations and so forth, right? So taking the idea of a PID loop and applying it to something relatively dumb like a thermostat is a whole other application of AI that I think we'll see happening much more frequently.
And that talks back to Ken's point about happening at the edge, right? I mean, that's AI right at the edge when you do it down at the thermostat level.
Yeah.
We have to put the thermostat in the right place. I see him right next to the cold windows that are freezing the pipe, and the people in the room aren't. I mean, even at AHR Expo, I saw some of the amazing technology where it's going to read back what is the actual temperature where you're at, not on the wall where some guy put it because it's the cheapest piece of wire. And
well, yeah, and the use of wireless remote temp sensors is getting pretty common, right?
Many of the systems are so poorly designed from an air distribution point of view that we don't know until we see that it's not doing what it was supposed to do. So I think
that's an example, David, and for us who've been in the space for donkey's years, we've seen that all the way back to the pneumatic days where these things would always be badly placed, location. And so one of the questions is, well, is that another opportunity for machine or AI, right? In that, right, rather than try and tackle the problem of and yelling at everybody, your thermostat's in the wrong place. And one of the reasons they don't move it is the cost to move them is horrendous, right? Because it's either, that's a lot of rewiring, and nobody ever moves thermostats for all these reasons. So the question is that another opportunity for AI? Okay, let's face the fact that they're always going to be in a bad place, no matter how well designed the building's going to be.
I'll just say that I have 3 proposals for a 33-story condo on an existing, a new BAS, and they're going to add these things. One wants $100,000 worth of sensors added to the building, but they claim they're going to get it paid back by a certain time. They're not going to trust the thermostat. The other one says, if we give you the thermostat that communicates, that'll save us money because it's fan coils, 700 fan coils being. And then you have the north and south side. We have the south that's getting all the solar gain on the same crappy window that's on the north. So I think AI will help us learn what's not working from a design point of view, whether it's, fault detection or the equipment not doing it or poor design, and then trying to overcome those differences.
And I think that's where I was trying to go, right, David, is that poor design is going to be, has been around with us as long as I've been around in this space. So can we use AI to compensate for poor design? I know that's not a good approach, but maybe that's reality.
One of the things that we've talked about is AI. It's much easier for AI to consume a lot more information. So is this not an opportunity to have significantly more sensors, because they can all be fed into AI and it could be sensing the room in a completely different way that is different to just sensing it at one point, right?
The right tool for the right job, as Jim mentioned. And the sensors are now, it's about the people sensor, including what's on their phone. So they can tell us where they are in order to get out of a building if there are gunshots. I'm just reading some of the amazing things that are being claimed in terms of first responders and the benefits that occur on these, campuses and getting people to find the right way out and avoiding fire. So I think there's lots we can learn from the benefits, but on the other side, it'll make mistakes, and who to blame.
And David, in the last minute, brings up a really interesting point. I mean, we've been heavily focused on energy and BAS systems. There are so many applications within the building that extends well beyond the systems that we interface with, right? Like David just said, get out of the building due to gunshots. What's the best route out, based on sound and whatever else analysis that you do. So,
we're coming up against the time here, but just one quick point I wanted to make sure that we brought out is, for the last however long, we all here have been working on open interoperable platforms, which is the prerequisite to inform any good AI application here.
Yep.
So, one of the evolutionary things is we are starting to actually see people integrating all kinds of interesting data sources and resources into their platforms to make more informed decisions like that, which really is a form of AI, right?
Yeah.
So it doesn't even have to be just more sensors. Now it's super easy for me to get a weather feed, and Google has that, right? And degree days and so forth.
Weather feed that is sort of hour by hour data,
right?
Not just day by day. So we're coming up to the end, and I'm going to pick on Mark because he's been obviously listening and observing. Do you want to share your thoughts as to what you've heard here, Mark? You're muted.
Muted.
I'll just say this. So today I purposely sat back and listened to colleagues and friends talk about this. And I tried to put that I'm a building owner and an operator and listen to this conversation. And with that hat on, I am confused as hell. I don't know who the hell's going to pay for this. What is the outcomes of AI for me trying to manage my 500 buildings or whatever? And again, I don't want answers, just again, as we explore this topic, I think as a group, we need to, those need to be future discussions as we continue this along.
And I think that's a wonderful segue to the fact that we're going to spend the rest of March digging into this, and this is the purpose of just having this wide open conversation to surface, exactly where we are. So that's a good setup for next week and beyond. So let
And
us
maybe
leave it
that
that.
doesn't, the people like from Passive Logic that claim they're putting it all into a single box, or somebody can make a presentation, Anto.
We shall consider that and consider other things. We'll obviously have some planning things, but we will come back next week to dig into this a little bit further. And in the meantime, hope everybody has a great week this week, and we'll get the video out tomorrow or Wednesday. So with that, bye all.
See y'all.
There you go.
Bye-bye.
Bye now.